Let us now look at how we can use Gauss's law to prove that a conducting shell cannot have an electric field inside. So here we have a shell, spherical shell, and it has positive charge on the outside. Remember we said that because of the charges spreading out, the electric fields are going to move the charges equally around the shell, and they're going to be in equilibrium, which is going to make the electric field cancel along the surface. So we want to prove what is the electric field inside the shell. So let's take a radius r, where r is less than r naught. In this case, we can write our integral e vector dot a vector is equal to q enclosed divided by epsilon naught. So the first question is what is the value of q enclosed? Well, there's no charge inside, so q enclosed has to be equal to 0. And once I make q enclosed equal to 0, I'm going to have, I'm going to simplify here, do the dot product. We know for a shell everything is 90 degrees, or I'm sorry, 0 degrees. So cosine of theta is 1. I forgot to put my differential in there. And that's going to be 0. And doesn't matter what my integral is, the electric field strength inside is equal to 0. Well, okay. Let's do a second example. This time, let's make r equal to some radius outside the shell. So our q enclosed, in this case, is just equal to q, because that's the total charge on the outside of that shell, and the Gaussian shell is this dotted line that goes to the outside, and it encloses all of that charge q. So I'm going to have the integral electric field dot differential area vector equal to q enclosed over epsilon naught. That's just going to be E times the integral, surface integral, is equal to q enclosed. Oh, we know q enclosed. Sorry, that's just q divided by epsilon naught, and that's just the electric field strength times 4 pi r squared equal to q over epsilon naught, and that just means that our electric field strength is equal to q over 4 pi epsilon naught r squared. So when I'm outside of this shell, as far as I'm concerned, it looks like the charge is at the center of the shell.